Everyone, hope you are doing well. I am Arimadit, a student of MSc Food Technology, Department of Dairy Science and Food Technology, Institute of Agriculture Sciences, Banaras Hindu University. Today we will discuss about the advances in food processing and preservation by heat treatment blanching. So let's start. Blanching. Blanching is a pre-treatment that involves heating fruits and vegetables to a predetermined temperature and maintaining it for a specified amount of time, typically 2 to 10 minutes. Product is then immediately cooled or passed to next process. It is a thermal treatment that is usually performed prior to food process such as drying, freezing, frying and canning. It is a pre-treatment necessary to preserve the product quality during long-term storage. Inadequate blanching may cause more damage to food than the absence of blanching does. The indicator enzymes. Enzymes which causes a loss of eating and nutritional quality in vegetables and fruits include lipoxygenase, polyphenol oxidase, polygalacturonase and chlorophyllase. Two heat-resistant enzymes which are found in most vegetables are catalase and peroxidase. Peroxidase being more heat resistance of the two is taken as an indicator organisms, but from the laboratory point of view, catalase is taken as an indicator enzymes and peroxidase as a theoretical. Purpose. Its main purpose is the inactivation of quality deterioration enzymes, enhancing dehydration rates and product quality, reduction in non-enzymatic browning reaction, expelling air entrapped inside plant tissue, increasing extraction efficiency of bioactive compounds, and reduction in the microbial load. The other purposes may include cleaning the surface of the plants, killing parasites and insects, removing damaged seeds, foreign material, and reduction in the oil uptake. There are two traditional methods of blanching: hot water blanching and steam blanching. Talking about hot water blanching, this is done at a temperature of less than 100 degrees Celsius. Blancher hold the food at 70 to 100 degrees Celsius for a specific time and then removes it to a dewatering cooling section. Blanching time is critical and varies with the time and size of the plant tissue. Talking about steam blanching is done at a temperature of more than 100 degrees Celsius. In this case, food is directly exposed to a steam in place of water. This process minimizes the loss of water-soluble compounds. These are some of the advantages and limitations of the conventional hot water blanching and steam blanching. Advantage of hot water blanching includes lower capital cost and better energy efficiency than steam blanchers. Its limitations include higher cost in purchase of water and charges for treatment of large volumes of dilute effluent, risk of contamination by thermophilic bacteria. The advantage of steam blanching include a smaller loss of water-soluble blanchers components, a smaller volume of waste and lower disposal charges than water blanchers, particularly with air cooling instead of water, easy to clean and sterilize. Its limitations include limited cleaning of food, so washers also required, uneven blanching if the food is piled too high on the conveyor, and some loss of mass in the food. These are some of the researches done on the steam blanching technology, taking different products like spinach leaves, kiwi fruits, potato strips, etc. and the different processing conditions. You may go through it and take a screenshot if necessary. So you can see here that generally the blanching time has been taken from 2 to 10 minutes. So innovative blanching technology has been emerged since ages. So we will discuss some of this. First is microwave blanching. Microwave blanching was started in 1940s. Microwaves are electromagnetic waves with wavelengths ranging from 1 mm to 1 meter, having frequency of 915 MHz to 2450 MHz. Heated material absorb microwave energy and convert it into heat by dielectric heating effect caused by molecular dipole rotation and agitation of charged ion with a high frequency alternating electric field. Electromagnetic energy is converted into heat energy in matter. It involves direct interaction between the electromagnetic field and food materials for heating generation. The advantages of microwave blanching include volumetric heating, high heating rates, short processing time, no leaching of vitamins and pigments, improved product quality and minimize the waste, capable of producing heat internally, high penetration power, and the heat is uniformly distributed in the material and very fast heating rate. The limitations include lost water during blanching, penetration depth of microwave is limited, difficult to precisely control blanching temperature. Its applications include carrot slices, mushroom, asparagus, artichokes, peas, herbs and spices. These are some of the researches done on microwave blanching, taking different products like carrot slices, carrot pieces, carrots, mushrooms, broccoli, sweet potato, asparagus, peas, etc., having different processing conditions, and the finding here are listed below. You may go through it and take a screenshot for further references. Now coming to infrared blanching. Infrared is generated by the electromagnetic radiation that falls between the regions of visible light waves, that is 0.38 to 0.78 micrometer, and microwaves 1 to 1000 millimeter. Infrared radiation penetrates into the food and directly hits the food. Infrared blanching inactivates enzymes and simultaneously removes a certain amount of moisture. Infrared blanching works on two heating modes, that is continuous and intermittent. In continuous, the radiation intensity is kept constant. It delivers high constant energy and hence suitable for quick enzyme inactivation. Talking about intermittent, it can be performed by operating the radiation using off and on modes during process. This saves energy and yields good quality products since the desired processing temperature can be minimized. The longer the wavelength of the radiation, the deeper its penetration depth. Therefore, food processing far infrared is frequently used. Some of the advantages include space saving, large heat transfer coefficient, high energy efficiency, easy to operate, contactless heating method, less energy consumption. The limitations include surface deterioration, non-uniform heating, poor heat penetration, charring due to the surface temperature of food products increasing rapidly, and overheating with time. The application includes apple, carrot slices and mango slices. In the picture you can see that the infrared blanching has been used in the mango slices. These are some of the researches done on the infrared blanching, taking different products like apple slices, carrot slices, mango, red pepper, etc., taking different processing conditions, and the findings here are listed below. You may go through it or take a screenshot for further references. Ohmic blanching. During ohmic blanching, food products are placed between two electrodes. Food products behave as an electrical resistance in which heat is generated and the product temperature rapidly increases. Rapid increase in temperature is followed by cooling. The frequency of applied voltage strongly influences the performance of ohmic heating. It was found that the heating rate decreased with increase of the frequency, so low frequency is frequently used. You can see that this is a picture of a blanched pulp from ohmic blanching. Some of the advantages of ohmic blanching include volumetric heating characteristics, less time, better product quality, blanching fruits and vegetables with a larger volume. The limitations include difficulty in controlling blanching temperature, generating oxygen and hydrogen, corrosion and electrodes. The application includes artichoke seeds, carrot, red beet and golden carrot, strawberries, blueberry pulp, fruits and vegetables juice and apple. These are some of the researches done on ohmic blanching, taking different products like artichoke heads, strawberry, tomato juice, sugarcane juice, blueberry pulp, apples, etc., having different processing conditions that are listed below with the products, and the findings here are also listed below. You may go through it and take a screenshot for further. Now we will talk about the effect of blanching on the food quality. Nutrients. Due to blanching, some minerals, water-soluble vitamins, and components are lost. Loss of vitamins are lost mainly due to leaching, thermal destruction, and to a lesser extent oxidation. This nutrient loss has been minimized from the advanced blanching technology like microwave, infrared, ohmic blanching, as well as steam blanching. Color and flavor. Due to blanching brightens the color by removing air and dust on the surface. Sodium carbonate or calcium oxides are often added to blancher water to retain the color of green vegetables. When correctly blanched, most foods have no significant changes to flavor or aroma, but under blanching can lead to development of off flavor or aroma during storage. So we should always avoid inadequate blanching. Texture. Due to the blanching, it softens the texture of vegetables to facilitate the filling into containers. Calcium chloride of 1 to 2% is therefore added to the blancher to form insoluble calcium pectate complexes and thus maintain the firmness in the tissue. Blanching is also one of the difference between fruits and vegetables, as blanching is generally done in vegetables, but it is rarely avoided in fruits. These are the references I have taken. Thank you so much, listeners, for taking times and listening to this.